in this page over here, we're going to talk about this test, okay? All right, so this is level H test. And the first question we have is 2 over 3 times x minus 3 minus 1 over 7 times x plus 1 equal to 1. So when you see fractions on both sides of the equation, what you're going to do is that you're going to find the LCM of the fraction denominator, which is 3 and 7. In this case, is going to be 21. So you're going to multiply both sides by 21. On the left side, if you multiply it by 21, you should be getting 2x minus 3 times 7 minus 3x plus 1 equal to 21. So you might want to ask, where does 2 come from? The 2 come from the 2 over 3 times 21. And then the 3 over here comes from the 1 over 7 times 21. So your goal is to eliminate any fractions appearing in the question. In that case, it's going to be making your life much easier. Okay, with that being said, on the left side, we have 14 x minus 3 minus 3x minus 3 equal to 21. 14x minus 42 minus 3x minus 3 equal to 21. So 14x minus 3x is 11x minus 45 is equal to 21. 11x is equal to 66, x equal to 6. Okay, so the answer for this one should be x equal to 6. So let's double check our answer. We multiplied this by 21, multiplied this by 21, multiplied this also by 21, right? So over here we have 14, no problem. So this is fine. And over here we have 3 times x plus 1, which is fine over here too. And last but not least, we have 21 on the right side. So this should be x equal to 6. All right, next page. Very good on the next page. Over here, for the first question, we are solving a simultaneous linear equation, right? Simultaneous linear equation. However, the format of this is a little bit weird. So what we're going to do first is that we have to move the numbers to the right side and all the variables stay on the left side. So in this case, 3x plus 4y equal to 11. 6x minus 5y equal to negative 4. Negative 4. And then I want to multiply the first one by 2. The reason why is I have the 3x and I want to get rid of x. Alternatively, you can multiply this equation by 5 and multiply this equation by 4 to get rid of y. No problem at all. But then in this case, I think it's better for us to just do the easy part, which is just multiplying the first equation by 2, and you will be getting 6x plus 8y equal to 22. And then you still have 6x minus 5y equal to negative 4. Then I will use this equation. We call it equation number 3. Subtracting equation number 2. So use 3, subtract 2. What you will be getting is 6x minus 6x is gone. 8y minus negative 5y will be positive 13y, and is equal to 22 minus negative 4 will be 26. So y is equal to 2 instead. Okay, so once you get y equal to 2, you'll be very easy to substitute this y equal to 2 into either number 1 or number 2. In this case, I'm going to be substituting into equation number 1. If I substitute sub y equal to 2 into 3x plus 4y equal to 11, I should be getting 3x plus 8 equal to 11. X is equal to 1. Okay? So your answer will be x equal to 1, y equal to 2 for question number 11. Okay? So I'm going to minimize this. And that belongs to here. Okay, just in case that you guys need to look at it a little bit later. Okay, for question number 12, and let's see what the problem is. Question number 12, again, our equation looks a little bit messy. So what I can do first, let's do something over here. So then, all right. Okay, let's do this. Yeah, let's change all of them into white. There we go, much better. Okay. Okay, now let's go back over here, change it into red. Perfect. Now we're having a new equation here. So first is I wanted to move my 7x and negative 5y together. So this will be, and also move the negative 8 to the right side. So this will be 7x plus 5y equal to 8. On the bottom, we have 3x plus y equal to 4. Once that's ready, and I can multiply this, call this 1 and call this 2. I can multiply this one by 5 because I want to get rid of the y, right? So once that's ready, what I will do is that I have, for the second question, 15x plus 5y equal to 20. And then I'll call this number 3, and I will use number 3 minus number 1. Once I use number 3 minus number 1, I should be getting 5y is gone. 8x is equal to 20 minus 8 is 12. X is equal to 12 over 8, which is equal to 3 over 2. So once that's ready, there's two ways to do it. First way is that we can substitute sub x equal to 3 over 2 into equation number 2, right? The reason why it's much easier, right? So we have 3 times 3 over 2 plus y equal to 4. And we just have to do a little bit more calculation over here. 9 plus y equal to 4. And this one will be 1 over 2 plus y equal to 4. It's pretty easy to get y is equal to negative 1 over 2. So x equal to 3 over 2 and y equal to negative 1 over 2 is my answer for question number 12. Alrighty, question number 14. Let's see, is there any way that we can do this one easier? So if you see, we can actually use question number 2 subtracting question number 1, right? So let's use question number 2 subtracting number 1. Notice that for this question, I'm not really changing any variables to the left side. The reason is because I already have y on the left side. It'd be easier for me to just subtract right away, right? So on the left side will be 0. On the right side will be 4x minus 8. So 4x is equal to 8, x equal to 2. So instead of negative 2, it should be 2. So once that's done, I can substitute this one into this or into this. I decide to substitute into equation number 1. So there will be y is equal to 3 times 2 plus 5, which is equal to 11. So x equal to 2 and y equal to 11. So the question really problem here is the negative 2 here. That's why it's a triangle here, okay? Alrighty, so this question over here, it's a 3 variable equation. Let's see what we can do for this one. Again, let's change everything to white. Okay, all right, and we're back. Okay, so in this question here, our goal is to form
What would that give us?
2 equations with y and z in it, right? The reason why is because we already have just one x, right? It's easier for us to get rid of x. So in this case, what I want to do is that first I want to use, let's call it number 2, number 1, number 3. Let's use 2 minus 1. When I use 2 minus 1, I should be getting y plus 2z is equal to 8. And that will be my equation number 4. And then I can use 3 minus 1 or 3 minus 2, doesn't matter, whichever works. I can use 3 minus 1. When I use 3 minus 1, I should be getting 2y plus 6z is equal to 22. So we call this equation number 5. And then I can multiply equation number 4 by 2. Once I do that, equation number 4, we call it equation number 4 prime, becomes 2y plus 4z is equal to 16. And we call this equation number 4 prime. And I will use equation number 5 minus equation number 4 prime. And I will get 2y is gone. 6z minus 4z, it will be 2z is equal to 22 minus 16 is 6. Z is equal to 3. Once I get z equal to 3, I can substitute z equal to 3 into equation number 4. If I substitute z equal to 3 into equation number 4, I should be getting y plus 2 times 3 equal to 8. So y is equal to 2. So now I get my z, I get my y, I just need my x. My x should be very easy because I can substitute y and z into equation number 1. So it will be x plus 2 plus 3 equal to 6. X should be equal to 1 instead. So at the end of the day, x equal to 1, y equal to 2, and z equal to 3. And that summarizes question number 17. Let's move on to the next one. Question number 19. Okay, so in order for us to do this question, we have to understand the sequence of our operation. When I say sequence, it means that which part do we calculate first? Do we calculate this first? Do we calculate this first? Or do we calculate this one first? So according to the rule of order of operation, we want to prioritize the exponents, right? In this case, the exponents is the 3 over here. So we have to really calculate this one first. When we calculate this one, this will be x to the power of 2 times 3 is 6, y to the power of 3, z is to the power of 3 times 3 is 9, and then we use 5x to the power of 3 times that. In this case here, 5 will time the whole thing, so everything will have 5 in it. X to the power of 3 times x to the power of 6, just to remind you that 3x to the power of 3 times x to the power of 6 should be x to the power of 9. So you're adding these two together instead of multiplying. Abby, you couldn't find the answer book. And then you have y to the power of 3, long day, buddy, z to the power of 9. So that's your final answer. 5 times x to the power of 9, y to the power of 3, z to the power of 9. Okay? All right, let's move on. Alrighty. Expand and simplify. So I can see that you have a 0x squared over here. The reason why is that if we have a 0x squared, we don't have to write it because 0 times anything is still be 0, right? So in this case, would be just x to the power of 3 minus x minus 6 instead. Similarly, with this one, if we have x squared, y squared minus 1. So this one should be eliminated as well. And let's see if we are doing it right on this one. Okay, so let's see what the problem is. If we use 2x times 3x and then 2x times negative 4, I'll get 6x squared minus 8x, and then I will use negative 5 times 3x and negative 5 times negative 4. So that will get negative 15x plus 20. Let's see what the problem is. I see. 6x squared minus 23x instead of 22x. Okay, so that's a calculation error over there. Sorry, that's a pity, but that's the best we can do. Okay, factorization. In factorization, question number 32, we have 4x squared minus 4xy plus y squared. In this case over here, what we want to do is that this looks like a perfect square. What is a perfect square? A perfect square looks like this. X plus y, let's say, it should be equal to x squared plus 2xy plus y squared. And let's see if I change things inside in terms of x, in terms of y. If I change, let's say, the x into a 2x, let's see what happens. If I have 2x plus y to the power of 2, this will become 4x squared plus 4xy plus y squared. Because you will see that the coefficient change correspond to what's changed inside. So now what we can do is that we can take a look at this equation. What can I see? I see that I have a negative here, which means that inside should be a minus for this perfect square. And then I see this is 4, and this is 4 over here too. Remember, whatever you have in the middle, it's basically the 2 times x and y, and this could be 2x, this could be 2y, so on and so forth. So in this case, since my 4x squared is there, so this should be 2x here and this should be y here. And let's verify if we are right. If we open this up, 2x minus y to the power of 2, You can literally even open it up like this. 2x minus y times 2x minus y. This will be equal to 2x times 2x, 2x times negative y, to 4x squared minus 2xy. And you do the same thing again. Negative y times 2x, which is negative 2xy again, plus y squared. So then you will have 4x squared minus 4xy plus y squared. And guess what? That's exactly what I have over here, right? So when we factorize it, we can always change it back, and it always work interchangeably, okay? So that's basically this question. All right, let's move on to question number 35, and let's see what the problem is, okay? So first of all, I see that we have the x to the power of 3, we have x squared, we also have x, and also we have 2, we also have 4 here. So immediately I know that I can factorize 2x out. If I factorize 2x out, if I take out 2x from 2x to the power of 3 from the first one, I would have x squared left. Keep the sign as positive. If I take out 2x from the 2x squared, I should have just x left. And then if I take out the 2x from the 4x, I should have minus 2 left. And as you can see over here, what I can do is over here, this looks like 1, 1, positive 2, negative 1. If I do that, I will see this is 2, this is negative 1. When negative 1 plus 2 is equal to 1, which fits the coefficient over here. Since you don't have anything before the x, which means that this is basically a 1. So my factorization should be 2x, x minus 1, x plus 2. Right? So let's see what the problem is here. Oh, I see. Plus 2 and minus 2. It's the final factorization is not there. So anyway, this is the final answer for that. Alrighty. All right. Next one, I have. So in this case over here, we have two separate terms. One term is 2 times x plus 4y to the power of 2. Another term is 2x times x plus 4y. Both of them will have, I can see 2, right? And both of them also have x plus 4y in it. So if I take out 2 times x plus 4y from this, I would have x plus 4y left, right? And by the way, I need to change it into a big bracket over here. And then if I take out 2x plus 4y from this guy here, I still have an x left. Okay, so now my factorization is done, but not all the way down, right? Because I still have to expand this inside the bracket and change the big bracket into a smaller bracket. So then my final answer will be 2x plus 4y, x plus 4y minus x. X is down, so 4y. So this will be 4y here times 4y. And then finally, this will be 8y times x plus 4y. Okay, and that will be my factorization for question number 38. And question number 39, this one kind of look like a squared minus 10a plus 25. The reason why I want to change the x plus y and x plus y into a is so that I can see this one more clearly. You always want to deal with the x plus y as a whole. In this case, how do I factorize a squared minus 10a plus 25? This is actually a minus 5 to the power of 2, right? That's a perfect square again. So then we can just simply swap a into x plus y. So the proper way to do this question is that we can let x plus y to be equal to a. So the original equation becomes a squared minus 10a plus 25. Once that's done, I can factorize this. When I factorize this, this becomes a minus 5 to the power of 2. Then last step is sub x plus y into a again. So then it will be x plus y minus 5 to the power of 2. That will be the final answer for question number 39. Alrighty, last question. X to the power of 4 minus 16. This is actually a formula that we can use for difference of square. So what is the difference of square? Let's say we have x squared minus y squared. This is actually equal to x plus y, x minus y, right? If I have x plus y, x minus y, in this case, but over here we have x to the power 4 and 16. So how should I rewrite this equation? In order for us to rewrite the equation, I can do x to the power of 2. So be a little bit more creative. Minus, so we are creating this perfect square. Does that make sense? Because 4 to the power of 2 is 16 and x to the power of 2 to the power of 2 is x to the power of 4. So now I have enough bullet for me to use. So I have x squared minus 4 and x squared plus 4. Notice that you cannot factorize this anymore, but you can factorize this again. So this one will be x plus 2, another difference of square, right? X minus 2, and then x squared plus 4. And that will be the final answer for question number 40. So I want you to kind of go through this whole test one more time just to see that you understand every single mistakes you're making. Hopefully we're going to retake the test next week to see that if you have a better understanding of the concept. Okay, thank you so much.